All right, well, let me do the problem of the month then.
And then I got a minor problem for you guys after that.
So is it time to turn on? Is it time to turn on the recording?
We're already recording.
Whoops, sorry.
So as I mentioned before the meeting started, I play pickleball on Thursdays, and it has aggravated my right shoulder a bit. So I'm going to physical therapy, and I'm doing some shoulder exercises. So this is one of the exercises that I do.
Actually, you're not the only one that should be doing that.
And so I'm using these can-do exercise bands. They come in different colors with different strengths or resistances. The red one is their light, and the green one is their medium. And they have at least 4 that are stronger and at least 2 that are weaker than these 2. And so I made up this little graph here to try to show what's supposed to be happening. Right? You start out with your arms with the bands not stretched, and you open them up, and you hold them there for a second, and then you slowly release them back in, and that tenses up your muscles as you open them and as you slowly release them.
So what's the y-axis?
Time.
That's the x-axis, isn't it?
Oh, yes, you're right. Let's say it's inches of extension of stretch of the band.
Okay.
It's not quite, but it's proportional to that. I just made up some numbers. So the problem is, I'd like to be able to collect some data on this so that I can review with my therapist to make sure that I'm doing them correctly, perhaps to pace me. She says to relax over 3 seconds, right? And so if I'm relaxing it over 1 second, I want something to tell me I'm going too fast. And then if I'm counting 1 Mississippi, 2 Mississippi, 3 Mississippi, I can't count how many reps I've done in addition to counting 1, 2, 3. Right? That's just something my brain does not do. So counting reps, counting up to 12, counting down 3, 2, 1, 12 times just doesn't work.
Well, so far, can I give you some of my quick thoughts on what you've described so far?
Sure. That was my last slide.
Okay. The first thing that comes to my mind is an aluminum bar with a strain gauge on it to measure the strain of the rubber band pulling on it. Number 2 is a metronome on a foot switch that you start with the foot switch for your tick, 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 running at 120. So that you just count 6 ticks if you need to do 3 seconds, and then hit the foot switch again when you go to do your relax and all that.
That makes it twice as hard. Now I have to count to 6.
Oh, booger. You'd probably have, I was still thinking foot pedals, but yeah, you'd almost have to program your delay time and hit the right foot pedal. That'll give you your 6-second alarm or your 3-second alarm or your 4-second alarm, whatever alarm that you need.
Okay. So I can imagine foot pedals activating a timer or something.
That way you don't have to count the timer, you just count your reps.
Okay.
Or you could measure, do your initial measurements of the strain gauge and see if you can detect when you start your exercise based on a delay, a delay of no activity before it. Then when you start doing strain, and see if it can count for you and measure how many seconds you're doing your reps.
Okay.
But yeah, years and years ago, I did some strain gauge stuff, and this just really lends itself right in for that, because that's exactly the kind of thing they were doing then. They were using bungee cords pulling down on something, but they were using a strain bar to measure the fact that the bungee was pulling.
Yeah, a load cell where the strain gauge is already applied to a surface would be a little easier.
I guess that's what I'm describing. We ended up gluing our own on, but yeah, you're right.
It's they're cheap enough if they're already glued to the surface, and you got to do it with special glue
that stretches.
And then the circuit would be just a Wheatstone bridge.
There's a rather nice Chinese chip that's used in most of the digital scales, which is 24 bits in like $2. It's an HCT. I'll look up the chip. But they come on a board.
HT711.
Yeah, that's it. They come on a board. They're simple to use. They've got two inputs. The code is Arduino code is out there for them, and they work kind of nicely.
Okay.
Are they more compression measuring, or are they more tension measuring? Because I think what Paul wants is something that measures tension.
Yeah, it's a Wheatstone bridge, so it will measure up or down.
It depends on how you hook the band to the load cell.
Mm-hmm.
And you don't want to have the cosine error as you're pulling off at an angle, right? So you need some way of rounding the corner, if you will.
Well, even if you're pulling at an angle, the strain is going to be normalized. 10 pounds is 10 pounds. The tension on the band itself will be.
Will be what?
Well, the tension on the band will be different, but even if you're pulling at an angle.
So you'll see tension on the load cell, but you won't be able to measure the tension.
You can measure.
You can measure the tension, but that won't tell you what the tension on the band is. It'll tell you the projection of the tension onto the band into the axis that's pulling on the load cell.
Correct.
Are you interested in knowing the tension, or do you just want to count?
Well, I'm interested in the amount of stretch of the band. So I'm interested in the length of the band, which is correlated with the tension of the band. I can imagine measuring the angle of the arm relative to the torso. That would give me the information I want. The amount of stretch, the tension in the band would probably give me what I want. The length of the band as it stretches would give me what I want.
I believe the temperature of the bands changes as you stretch them. There was a guy on YouTube who actually tried to build a refrigerator using stretchy rubber bands.
Okay.
And so if you're just counting, a thermocouple on the rubber bands would help, or you might be able to sense that reliably. And there may be a correlation between the tension on the belt and the temperature.
Okay.
Also, my physical therapist said if you're counting stuff, he said the best thing to do is just set a timer for a minute and just do it for a minute, and then, or whatever number turns out to be, however many reps you want, and just go that way. And it doesn't matter if you're one shy or one over kind of numbers.
Yeah. I guess my concern is the 3 seconds of relaxing, right? So just flinging your arms back and forth for a minute is not the same as opening them up and slowly releasing them, opening them up and slowly releasing them.
Yeah, when you lift weights, you're supposed to do it as well. You're supposed to push, when you lift the weight, you're supposed to lift it quickly and then let it drop slowly.
Yep. But, assuming that they're done correctly, I can see where just a timer would get you the right number of reps. Other ideas? I like temperature. That's a thinking outside the box.
There are fabrics, which I may have some, that change resistance as you stretch them. They're kind of a crude load cell, but you could run that parallel to the stretch band.
Okay. So fabric that stretches and changes its resistance. That'd be cool.
Isn't there some strain wire as well?
That's what I was, yeah. It's basically a fabric with a carbon embedded in it. And when you stretch it, the carbon kind of stretches.
Oh, I was thinking more of a like a muscle wire.
Um,
I don't know how accurate it is or whether you can get proper readings from it.
Well, you could do a muscle wire thing, then you wouldn't have to do them.
What about an ultrasonic sensor that, in addition to the band, you held, some kind of paddle or something that the ultrasonic sensor would measure the distance?
I don't think you'd be accurate enough.
No.
I made a gadget that.
Oh, go ahead.
Go, Pete.
I made a gadget that does exactly that. It's actually designed for weightlifting, but it would measure. Well, the problem is that the target you're trying to measure the movement of your arm, right? And my gadget had a bigger target, so it was used for a type of lifting called squats, and it would basically tell you when your butt was exactly the right height for on the way down for doing a squat, for finishing a squat. But the ultrasonics are plenty accurate enough if you have a target that's repeatably in the right place, and I think that would be a big problem. Your movements would be it would have to somehow track that you were moving your arm up or down versus straight out like the previous time. But anyway, enough of that.
If it were connected on the band, that would aim the ultrasonic towards your hand, and it would change.
Yeah, it probably would. And in fact, yeah. And if you want to play with this gadget, I've still got it, and I think I can dig up. I know I can dig up the code for it, and it's accurate. For me, it was easily good to an inch.
Okay.
And nowadays they've got them also that are like ridiculously accurate with time of flight sensors that are off the wall. How they do that, I don't know.
Yeah, if you line it up with the band and have some kind of a target that's hooked up at your hands, that's going to stay lined up.
Yeah, that's it. Hold a ping pong paddle.
Yeah.
I mean, have a ping pong paddle taped to your hand.
Okay.
No,
so I was
don't do
thinking one of those fish scales you weigh fish with.
Okay.
has memory card and Bluetooth. I guess it would log it, like each pull to the memory card, but then you'd have to pull that memory card out and maybe run some type of Excel.
Yep, that would be fine for
record it.
reviewing with the physical therapist. So it's been a long time since I've done much fishing. So fish scales are now electronic, and they have SD cards.
Yeah, I'll throw a link. I have it right here. I'll put it in the chat. My friend has something. It reminded me of my friend has a precision rifle, so he has something to measure his trigger pull like that.
I have some. I put a link to a eBay, but I have some of these if you ever want them.
They have similar scales for weighing packages and stuff too, that you can hold up.
Yeah. So any guess as to how much pressure these bands are? How much
Well,
tension,
the load
how
cell
much resistance?
The load cell I have will do 50 kilograms, which is probably less than you're pulling.
No, it's way more.
I mean, yeah, you're pulling probably less. Put it that way.
Yeah. So am I pulling more than a kilogram or less than a kilogram?
Probably about 2 or 3 kilograms.
Mm-hmm.
Okay. So a 10 kilogram load sensor might work. I have one of those.
That would work.
And I ordered some HT711s. So this is probably one that I will actually implement and report on next month. All right, any other ideas?
Did you do anything
It
with your
occurs-
plants?
I'm sorry, Carl, what?
Did you do anything with your plants from last month?
I brought them in and I put them out. I brought them in on Friday and I put them out this morning.
I was just going to say, Paul, you may want to pace yourself so that your PT doesn't complete before the project.
Okay. I go to PT tomorrow morning. But okay, other ideas? All right. So we've got a presentation from Keven.
Oh, all right.
And
Hey, before we get to that, I had an article that I just saw in Elector magazine.
take the component identification quiz. I see a couple of resistors.
Yeah, I've seen these before.
What's the red thing with the the red cherry with the
Diode,
green
I bet.
hat?
That's G. Let's see what it says G is. It's got the number visible 431 on the red blob. It turned out to be a 430 volt VDR.
VDR.
Voltage dependent resistor. I would actually share the page if my subscription didn't just run out on the magazine. They won't let me download the article anymore.
Bummer.
And it's like $300 for the next 3 years of subscription again because it's a European magazine.
Do they have a electronics only version? It's cheaper.
That is the electronic only version where I can download individual PDFs of each issue and all that.
Yeah.
But unfortunately, the one that I'd signed up for 8 years ago ran out, and at that point in time, it was costing me only $25 a year.
Okay, Kevin, you think you're ready?
I am.
Great.
Let me. All right. So while I'm on camera, I didn't have any RTL SDRs. This is a HackRF One that we're going to be playing with today, and this is about a $300 unit, which is clearly more expensive than the RTLs, which go for $30 ish kind of numbers. This one also has a transmitter in it, which lets you do some hijinks as well. So that's the hardware we'll be playing with. And at a Hamfest sometime, I bought a couple of wireless doorbells. So when I press this, I get the doorbell thing going on, which is really irritating. So I'm going to stop that. But I'll tell you when I click on the doorbell button as we play with these. So let me share my screen. Also, I don't have my usual equipment with me, so if I fade out or the audio gets wonky, let me know and I'll adjust. And also, let me show you screen. Oh, that's interesting. All right. No, we're going to get weird. Okay. All right. So let me show you the block diagrams. So this is the block diagram of the HackRF One, and this is a lot more complicated. I'll show you the block diagram of the just generic RTL SDRs. And just in case you don't know, SDR means software defined radio. And so this one here's the antenna down here. Can y'all see my cursor move?
Yeah.
Yes.
Okay.
Yep.
So the antenna's down here. This is a 1 megahertz to 6 gigs unit. They do some switching with some gain control in here. And the real magic is this MAX 2837 chip. It takes in data from the antenna this way, does some quadrature conversion, and then goes into an ADC. And then this is the stuff that gets presented to the USB port on your system. And so that's the real magic of the whole thing, is to be able to take the antenna, take it down to some frequency where you can digitize it, and then get bits into the USB port. There's a ton of different hardware out there that does this, and part of the complexity of setting these things up has to do with the fact that there's different hardware with different capabilities. So there's setting it up initially takes about a day just to get all the drivers and stuff set up, and so that's based upon your hardware. But once you get it set up, a lot of the software is works fine. And then, so the Misty folklore goes that there was a chip, an RTL 2832U, that some hacker had found out you could put into a debug mode. So this chip is for demodulating TV, DVB, CO demodulator kind of stuff, and they found you could put it into a debug mode, come in from the antenna, go through this quadrature conversion thing, low pass filters, resample it, and get data out the USB port. So you can get these raw samples out the USB port, which is, again, what all the hardware wants to do. And once you've got hardware that does that, it's a software problem at that point. Okay, so I have my HackRF One plugged in, and if I list my USB devices with the LSD command, there's my guy. Whoops, that's my HackRF One. Also, I'm on a Ubuntu 20.04 box. Just FYI, I'll post some of the notes of this stuff into the chat when I'm done. So it shows up as a USB device, and so once you have that, put some of the stuff there. So this is a piece of software called GQRX, which is this is dual platform, so you can get this on both Windows and Linux. The other side of it is there's a whole bunch of different software that works with these things. Some of it works on Windows, some of it works on Linux, some of it's dual platform, which is again why it takes about a day to get all this stuff figured out. And the I/O devices here. This is how you control the hardware itself. And then, let me load a setting. So, no, let's see what happens. So this, I've just set it up for the FM band. I'm here in Chapel Hill. So this is 91.5, and you may be able to hear that audio coming through. So this is centered up on 98.5. I'm going to mute the audio. So this is set up on 98.5 or 91.5, which is a strong signal here where I am. This is interesting in that first time I dealt with FM radio for a long time, didn't fire up a spectrum analyzer for about 10 years. And the next time I fired up a spectrum analyzer, I didn't understand what I was seeing. This guy here who's wiggling around, that's the audio for the analog audio that they used to transmit and have transmitted since the 50s. These two square guys in the next channel over, they're still associated, even though they are on the next channel, they're still associated with 91.5. But that's the digital data coming through, and they the FCC specs say they have to be a particular amount of power below the main analog carrier. They have to be situated on a non-interference basis, all that. So this is actually a quite complex waveform. I think this is OFDM, both these sides there. So anyway, so it's pretty easy to set that up. What it's doing is it's coming off my antenna to the HackRF into the software, and then this is all a software environment.
That's WNPR, NPR, the WUNC affiliate.
So
and it's phase modulation, so the stronger they broadcast, the wider their bandwidth has to be. Yeah. Also, since all that demodulation is happening in software, it puts a load on your machine. So the reason I stopped it just then is because y'all were breaking up and I couldn't hear anything what you guys were saying. So, but also jump in if you've got questions. So let me flame that up again, and I'll show you another thing we can do with it.
I assume you're going to tell us how it tunes the antenna to 91.5?
Well, it happens here. You go into I/O devices, and this is my HackRF One. And if you have a different radio, this checkbox will come up with a different one. So these are all the other ones that you can do. And depending upon what drivers you load in, this box gets filled up with other things, with whatever else you've got. So this is my HackRF One. To set the frequencies, you just go up here and 0, 99.5, hit enter, and then you have to run the DSP. And so there we are. we're farther apart now. We're looking at the whole spectrum. We're looking at spectrum from 96 to 103. So there's a lot of DSP that you have to be fluent with to kind of understand a lot of what's going on with these things. There's a sample rate, which is that number right there. And my HackRF only lets you select a certain number of those. And the higher the sample rate, the wider the bandwidth you'll see, but the more load on your machine because it's got to take in more data and process more data. So there's a trade-off there. But this is so this is the FM band. This is what's that?
Hey, Keven.
97.9. Yes, sir.
Hey, when Phil Rhodes and I did a presentation on SDR at Trilug,
yes,
I think it's about 5 years ago now, maybe 6 years ago.
Mm-hmm.
Phil did the FM band like you were showing here, and I did shortwave and also airport and railroad frequencies.
Mm-hmm.
And the thing that's interesting is because it's SDR, you can pick out both sides of a conversation if they're doing a half duplex style conversation. And also there's digital decoding sometimes involved with emergency vehicles.
Right. We'll show you a little bit about the digital decoding stuff. I played with this last time right before I retired in 2004. And it's changed a lot since then. One of the ways they're trying to solve the various hardware issues is they put in a interface module called SOAPY, SOAPY, that tries to form it forms a wedge between whatever hardware you've got and standardized software. So, which is a completely new thing that they've done again over the last 5 years or so. So, there's been a lot of work going on. Anyway, so here's the various FM channels, and you can set up to demodulate them. The I/O devices here is how you set up your hardware. Let me show you. Yes,
one remark about the receiving, the tuning aspect is that the hardware is getting a very broad piece of the bandwidth, and you're tuning using software. So the entire FM broadcast band is, in a sense, is absolutely being captured, and it's just a software issue as to what part of that information you tune into via software.
Partially true. So there's, when you go into the I/O devices here, this input rate is effectively the sample rate. So that's directly related to how much bandwidth you can capture. So you can set this to a low number, and you can also decimate it, which means in the case of 2, it means take every other sample, which effectively cuts the sample rate in half so that less data goes into your machine, and so your machine doesn't bog down as much.
Yeah, I should have said, depending on how wide you can't get the entire RF spectrum, but depending on your hardware, you can get large swaths.
This one will get you 20 megahertz, which is not too bad. And I'm not quite sure what the other ones get you. I don't recall.
That's the entire FM band. 88 to 108 is 20 megahertz.
That is the entire FM band, yeah. But you can't get any more than that. If you wanted to do the FM band and the aircraft band right above it, you couldn't do it at the same time. But you can tell it, give me a swatch of spectrum from 100 to 110, then give you another swatch of spectrum from 110 to 120, 120, 130, and then stitch it all together. And there's software available that does that. So a lot of the software works over the problems with the hardware.
Can you just change the center point so that you can move the band linearly through the spectrum?
Oh, absolutely. If you change this number right here, you'll go to a different frequency. Well, while I'm on this, before I monkey with this, I'll show you that in a second. Let me show you the wireless doorbell. So let me pause it here. You see this spike here? There's a phenomenon that occurs in all these radios that if you tune it to a particular frequency, in this case, I tuned it to 433.89. It'll always show a spike at that frequency. So normally what you do is you tune it to a frequency that's not quite right, and then you look over here somewhere, and there won't be that effect won't be there. So our signal is going to show up right here because of the way I've tuned this whole thing. So pressing the button, so you can see that's my wireless doorbell. And this thing operates at 433.92, which they've put on the back of the device conveniently. And there's a world of things that operate at 433.92. Most of the weather stations, they'll transmit from the local or from the remote device to the local device on that frequency. There's a couple of other frequencies as well that they pop with. So anyway, so that's one piece of software amongst a plethora of other pieces of software. This happened to be the one that was easiest for me to get up and running in a short period of time. But there, like I say, there's other ones, and let me show you a couple of those. Anybody got any questions about this one before we boot out? Okay. I'll put the websites to all these things in the chat. There's another one, another interesting piece of software called RTL 433. And what happened was, like I said, a ton of things happened at 433.92 megahertz. Simple digital devices. When I fire this up in an urban environment, you'll see alarm systems like telling you that the window is still closed, the door is still closed, that sort of thing. You'll see tire pressure monitoring systems. So you know when all your wheels on your car have a little radio in them that transmits to your car that tells you whether or not the tire pressure is low or not. Those all have unique identification numbers, and they transmit, I think, about once a minute or so to the car. So those are available, and I can't remember the frequency of those, but they're out there. So someone started writing RTL 433, which was just to pick up all these signals at 433 megahertz and then decode them. Let me show you the website.
Yeah, as a matter of fact, I'm sort of in the smart home Internet of Things, and a lot of home automation equipment is in that band.
Exactly. So here's the, this is GitHub, and this is where I pulled it from. And unfortunately, when I run this thing, you're not going to see this here because I'm in the middle of nowhere, and I don't have anything that transmits that this thing will recognize. But it recognizes a plethora of things. And so this is the kind of thing you get out. It'll tune the frequency to 433.92, and then you'll see, you can put it in several modes. You can put it in analysis mode, and if it sees a signal, it'll try to tell you what it is. Or you can put it in, just tell me what the bits are, or tell me what the thing means. So let me run this. This isn't going to be exciting. And it turns out that my little, stand by, please. It turns out that my wireless doorbell is not in one of the devices. So it's tuned to 433.89, which is actually where the frequency of my doorbell is when I went and measured it. But if you look, it's not telling me. Oh, there it is. So there are a number of protocols that it has, that it recognizes, and you can add your own protocols to it. They have an API that you can go in and describe what your signal looks like and what the bits mean, and you can add them to this program as well. And as I said, you're going to see nothing here because I'm in the middle of nowhere. But if you're in an urban environment, you'll see packets just wheel by. It's really pretty interesting. And when I key on my wireless doorbell, keying it, nothing happens because it doesn't recognize the protocol on that. So anyway, so that's another one that's I found pretty useful or pretty interesting.
So it doesn't say I saw something, but I didn't recognize the device?
It does not, no. I think it can. I didn't go deeply into this, but I think there's a lot of meat here. When you start to look at the GitHub page,
I got some old VHF wireless microphones that, now they've had to move to new frequencies.
Mhm.
But some of the oldest ones are in the 433 area. And if you want to pollute that band, I've got some really good RF signals for you.
well, it doesn't have to. That's the other thing, is it doesn't have to be in the 433 band. There are several other frequencies that things transmit in, and you can actually tell this thing via the command line, go to this frequency, hang around for 10 seconds, go to this frequency, hang around for 10 seconds. So you can actually tell it to go bounce around. It's a little like Linux, is that there's a lot of functionality in here, but you really got to kind of know the zen of the whole thing before you can get it. These are
510 and 533 are also.
Yeah. 890, wherever an ISM band is. But here is some of the ones. These are the ones that it supports just out of the box. So
you're running this on a Linux machine?
I'm running this on a Linux machine. Yeah, this is all Ubuntu.
Oh, that's right. You said 20.04. Yeah.
Yeah, this is all Ubuntu.
Yeah.
So anyway, so that's another one that you can use these things for. And the big one, or the most complicated one, what do I do with my one window, is gnuradio. And so gnuradio is, my understanding is it's a Python connection into the SDRs, so that you can actually take in the data off the SDR from the USB, write Python scripts to actually go process all the data. So that's complicated and hard, but they wrote a program called GNU Companion, or GNU Radio Companion. And this is what it looks like. So, and this is another one that you need to spend some time with it before you get really fluent in it. If I open up a new radio, so this is what it looks like when you first open it up. You have options here, and you can have variable blocks. And so these are what you get standard. And so one excellent use is the Control F key, lets you find things. And GNU Radio talks about sources. And this is my HackRF source right here. And so if I take and I drag that over, it'll give me a SOAPy, which is that interface I discussed earlier, HackRF source. One of the features of this thing that use color to good effect is if the labels are red, that means there's something wrong with the box, or something in the box hasn't been satisfied. So for example, in this case, and to go into the box, you just click on it and it'll bring up a properties box. And the problem with this is there's a variable called frequency that is not set. So so I'm going to open up, I'm going to copy this variable box and then paste it. And so here's another variable box. I'm going to go into that. I'm going to call it frequency, which is this frequency here. And I'm going to set the frequency to our friend 91.5. That's one more zero, right? Yeah, so that we're going to go back to our radio station at 91.5 megahertz. And hit OK. So notice now the center frequency is not red anymore. So that means it's happy. The other thing you can do is I have to cheat here and hold on for stand by, please. I'm just going to copy this. So this is if you type GUI sync here in the find box, so this is that box here. I just couldn't find it, so I could drag another one out there and I'd get the same thing. But then, so again, this is red because it's unhappy about something. So you click on the out and you just connect the arrow to the in. Also up here, it's telling me that there's an error as well. And I happen to know what this error is because I've played around with it today. It doesn't like the fact this ID is default, so I'm just going to call this foobar. So everything's black, everything's happy. We're going to hit run. It's going to. I need to save it first, and I'll save it as untitled. Just fine. And so when we run it, what it does is it generates Python. Oh, I didn't set the sample rate correctly. It actually generates a Python file and then presents that Python file to the gnuradio engine, and then it runs. I need to change the sample rate on this. Oops. Setting the sample rate to 20 megahertz. That error means I set the sample rate to something that was incompatible with my hardware. And so now I'll run it. So it's generating Python, and then you get this the spectrum of our radio again. This is, again, you have to know a little bit about DSP, but because I set the radio to 91.5, I know that this is 91.5 megahertz. And you get, it puts up automatically different displays. There's a waterfall display. You get a time domain display. And the constellation display isn't very interesting unless you're doing digital data. So I have one that is just set up for the FM broadcast band. And so there's my HackRF. There's my GUI sync right off of the HackRF. I connected this to also a resampler to bring the data rate down, an FMD mod, and then we can look at that in another GUI, and then we'll also dump that to the audio. So when I run this, I'm not sure. Whoops, I have to stop that. I got to figure out. Stand by for a minute. When I run this, let me figure out how to turn off the volume. So I couldn't figure out how to turn the volume off. But if you notice, there were two windows on top. One was this GUI sync, and the other one was this GUI sync. This was demodulating the audio, and the audio I had dumped into my output. Yeah, I can kill it that way. Let me run it again. You also have the ability to disable boxes, which is what I just did there. And so this is the spectrum right off the air at 91.5 megahertz. And this is the audio spectrum coming out. And again, we get waterfalls and we get time domain spectrum as well. And finally, this is my wireless doorbell. Again, I did the same thing as you just drag boxes from this part over here. And they have a ton of things. You can do digital television. All these widgets are available to do very complicated things. But when I run this, oops, I dropped my. pressing the doorbell button. So there's my doorbell button. So again, this spike here is an artifact of just the way the hardware in the radio is set up. I have the hardware tuned to 343 megahertz, or I'm sorry, 434 megahertz. And when you do that, you get a spike at that frequency, just again from a artifact of the hardware. So normally what you do is you set this so that that's at the center frequency, and then the signal of interest is over somewhere where the spike won't be interfered with. One more thing to show you, and then you can call it a day.
Which of these tools do you find yourself using the most, Keven?
I've used the gnuradio companion a lot, but I was doing a lot of digital signal processing at the time. If I just wanted to show a spectrum, if I'm setting up an antenna and trying to turn an antenna around, I would probably pick the GCRX guy. So it's really if you've got a problem, something you're interested in solving, you're probably not the first person who has had that problem, and there's usually software out there that'll deal with it. So just on the web, so what people have done is they've taken these these SDRs, and they've put them on the web. So you can access these SDRs from, like, this is a guy in Germany. And if you click on him, I'm not sure what's going to happen, but this is another piece of software that you can find. This is, I think, is a Windows thing. But right now we're listening to things in Germany. And
that's the 80-meter band.
And so a lot of it depends on, what's happening here? My computer seems to I've overloaded it. I have to get out of this. This window is locked up. Like I say, this puts quite a load on your system, and also we're doing a web thing. Hold on for a minute. Right.
So Keven, if you had one of these remote temperature sensor things,
mm-hmm.
and you wanted to intercept the broadcast from the sensor to the base station, it seems that that's doable. Are there tools for decoding what gets transmitted? And such that you might potentially be able to snoop it and figure out what the temperature is?
It could also be used for finding bugs and stuff.
If you had a protocol analyzer, yeah. I've seen something like this pick up RTTY as well, which is your frequency shift key and kind of stuff.
Kevin's trying to regain control of his computer. I think it probably went into swapping.
Okay.
So, many years ago, about the mid-90s, gnuradio was brand new. Oh, here he comes.
Hi. Yeah, I overloaded my machine and Brave got upset. What was the question?
So if you have a if you have a remote temperature sensor and you bring up the SDR and you can see it, transmitting, and so you know what frequency it's on, that's probably on a label or something. Are there any tools for debugging what's transmitted and potentially reverse engineering and being able to tell what the temperature is?
The SDR 433 has, normally for most stuff, someone's done it before, and it's often pretty easy to find things on the
Actually,
net.
there's some older HP software that might still run nowadays that, given the waveform, the output, it'll actually sit there and analyze the protocol and debug the protocol itself. Because it used to do that for line modems and with an analog signal and stuff. And once you've sampled it, once you've got a sampled, say, .wav file, you can there's a lot of software out there for decoding and debugging.
Wow, there's one more thing I want to show you. Yeah, in fact, I bought a Costco weather station, and RTL SDR understands that. So it'll tell you actually what the temperature is. And as I said, I've looked at alarms. I've seen alarms, and instead of just saying this bit's a 0 or 1, it says the window is closed or closed. So it will actually give you the status of the alarm. I'm going to share one more thing in my screen.
Hey, did that check? Do you know if that software has a protocol already set up for RTTY?
I don't know.
The only reason why I bring that up is the International Space Station this last December sent out a bunch of pictures, and there was a lot of people around the world that use SDRs to pick off the picture data and decode it down. I forgot what they use for the decode on it.
Yeah, there's software out there that'll decode those things. So this is a map. Can y'all see this this screen?
Yeah.
So this is a map of SDR radios around the world that this particular site knows about, and you can zoom in. Well, I think it's locked up again. Oh no, there you go. So you can pick one of these, and it'll go to it, and you can watch what's going on. I think one of the things that's happening, you know how they've been tracking oligarchs' boats, and they were tracking Elon Musk's plane for a while. There's a plugin for SDRs that'll let you get the ACARS or AIS data off of planes and ships. And I think what they were doing was using SDRs stationed around the world like this to read that data to try to figure out where his plane was or where the planes are. But there seems to be some power in that. I'm going to stop sharing. Anyway, that was the last thing I had to talk about.
Hey, Kevin, are you familiar with helium? It's a specific application of SDR that's they're using them to basically both broadcast and receive in a mesh network style of fashion. And we'll ignore the cryptocurrency side of that whole thing on helium, but on the radio side of it, basically it's specialized SDRs. And I forget which software or what Python scripts are using to do it. I'd have to talk to a couple other guys that are big into that right now.
No, I don't know much about that. I know the transmitter gives you a little more functionality. There's a guy on YouTube named Valent Seeger, I think his name is, and he works for the HackRF people or Edis or another one of the SDR vendors, and he does things like the little pucks you get at restaurants that sit that beep when your tables are ready. He has software that'll go out and talk to those things, and then so you can tell you can make other people think that their table's ready, or you can make everybody's table light up. All kinds of things like that. There's also replay attacks you can do with key fobs and stuff like that the transmitter enables you to do. There's also, I think it's Pen2 Linux is a penetration testing Linux that you can get on a live CD, and it has a lot of these SDR tools on it. So if you want to do that, you can do that. Okay, that's really all I had to say about that.
Well, thank you, Kevin.
Sure, my pleasure.
Pete, are you guys ready for a Aardvark?
That is that's a theoretical question. Let me see if I can do screen share.
Can I ask, what was the specs on the system you were using? Like, what do you recommend to run something like that? I've seen Kali, Linux, and some tools like that. Is that a quad core you're running?
Who are you talking to?
The presenter.
The SDR stuff?
Yeah.
I'm just running it on, I think this is a quad core computer, probably 5-6 years old. The more DSP you want to do, obviously, the stronger the computer needs to be. I don't really have a good recommendation. I know people run some survey stuff on the Raspberry Pi, and they do war driving. You could drive around. And one of the things on my to-do list is I just bought a 2020 Highlander, and from a privacy perspective, I'm really curious to know if it's transmitting out my GPS location kind of stuff. And so I want to take an SDR and just set up my car and see if it ever transmits. But I could do that on a laptop, and I don't need a Raspberry Pi for that. I don't need to be covert with it.
I took a Pixel and I installed the Kali version on it. But it's got limited, from what I've read, power. Most people seem to like laptops. I just wasn't sure what a good laptop would be.
Well, in the TriLug meetings, they are using Pis for SDRing, but it's your basic telemetry. It's not whole bands of a whole lot of stuff. You know what I'm saying? It's fairly narrow band of information, and content frequency width is pretty narrow.
Are they using the cheaper adapters then, like the RTL isn't?
I don't know. Probably.
I would have to ask the professor that's been presenting at the meetings.
Okay. I'll keep an eye out for that.
Okay, can anybody see the slides?
Yes, we do.
Oh, good. Technology.
You got it working?
Okay, so this is going to be brief so that we can get on with the next stuff, people that want to share and so on. This is an update, and some of you are new to this project, so we're going to start with this first slide. So a few months back, we started a project to combine a popular MPU, namely the ESP32, with field programmable gate arrays as a means of making interesting projects that have requirements that are difficult or impossible to do with MPUs, but are straightforward to do with FPGAs, but also to make FPGAs more accessible and get more people interested in them. And so we organized a group. There are currently 26 people involved discussing this stuff, and we've got some prototype hardware going. We're starting off aiming at making something very, very inexpensive, and we've got some prototypes that I'll show you in a minute. So the status of the hardware is that we made an initial prototype called version 60.
Pete, are you changing slides, or are you still on slide 1?
Shit, I was changing slides, but I'm guessing that they're not changing.
No, we're still on 1.
Son of a, I mean, sugar pops.
So you almost got it working.
Yeah. Piece of, yes. Okay, let's see. Go back to the beginning. Do you still see me, or do you see the...
No, we see
the editor with slide 1
up. We see the editor.
Ha, fantastic.
For slide 1.
Okay,
Quick,
can you see slide 1? All right, so there's slide 2. Do you see slide 2?
We do.
Yes.
There you
Yes.
go.
Okay, let me just go crazy and wild with this thing and restart the slideshow and see if it actually works.
Continue. Just continue. Do
Just
not.
go to slide 3.
Yeah.
Like
Just
success. Do not mess with it.
it works.
Yeah, this really tests my patience. So anyway, I already said most of this stuff. This slide describes what I covered earlier, that we're trying to make a combination of a very, very popular MPU, the ESP32 family, combined with gate arrays. And we're initially focusing on a mixed signal gate array that's relatively simple and extremely inexpensive, made by a company called Dialog. And we've come up with prototypes where the parts cost is easily under $10. Next slide is about the prototype status. We started with the versions before .60 were just on paper, and we started with the version 60 with a relatively small board. From memory, it's about 1 by 3.5 inches. I think it might have been 1 by 3. And it just has its absolute bare bones. And then version 70 added a USB interface for convenience. And that is, there are 3 of those. We've got 3 boards. One is populated and up and running, and the other 2 will be populated and distributed at the next face-to-face meeting. So as I mentioned, there are 26 people involved, and we will be meeting at the Cary Abbey Road Tavern and Grill in Cary on Chatham Street. If anybody is interested in this, just send me a note and I'll get you hooked up. We're using Signal as a way of chatting and sharing files and so on.
What date was that?
But we'll have a face-to-face, and the meeting, we have a private meeting room. It's relatively small, and I've got a HEPA 13 filter, and we can each use whatever precautions we'd like to use with respect to the pandemic. But it's really, really calmed down, and
that's 2 weeks from tonight.
And it's 2 weeks from tonight. It's the 28th of March at 7 p.m. So I will send out a reminder when we get a little closer. And again, if you are interested in this, let me know, and we can connect you up. We've got the version .8 board on paper, and it's going to, the version .7 stretched from 1 inch and 3 to 1 inch by 3.5 inch, 1 by 3.5 inches. The version 8 board, we're going to go offshore for the PCBs and use 10 by 10 centimeters form factor, which we can get very, very inexpensively. And the reason we're going to go with that is so that there's a very large area of the board that's uncommitted that people can use to put their own designs onto. Nick has also come up with an idea of a simple bus system that should allow us to have the base board relatively constant, but allow the addition of daughter boards that have the customization. This is a picture of the .7 board with, on the right, the little green daughter board is a Dialog mixed signal FPGA. It has an instrumentation amp, an extra op amp. It's got counters, It's got comparators. It's got 2 digital rheostats that can be combined into a digital potentiometer with 2,000 steps. It's got clocks, bunches of lookup tables for doing digital logic, and the tool for, I should have put some screenshots of the tool. That would have been a good idea, but we can have that for next time. The drag and drop GUI tool for configuring this FPGA is extremely sophisticated, very, very easy to use. So anyway, this is the .7 version with the hold on just a second, I got the wrong, okay. This is the .7 with the Dialog FPGA, but it also supports the GreenPack, the Dialog GreenPack programming adapter. And this, believe it or not, can you guys see my my mouse moving around?
Yes, we can.
Okay, so this part right here swings out, and it holds the ridiculously small QFN chip, such as the 47004 that was in the previous picture. It was in the middle of that little green board. And this is a socket for holding very small surface mount components. And the whole thing plugs into a separate set of headers here, and allows programming the chips prior to them being reflow soldered or hot air soldered or vapor soldered into the target PC board. Here's a quick. Yes, sir.
Slightly unrelated question. That red wire, is that old wire wrap wire?
It certainly is.
Oh my God! How did you even find that stuff?
I bought a lifetime supply about 25, 30 years ago.
Oh God!
I have enough wire wrap. It's called Kynar insulated 30 gauge wire. It's really, really good stuff, and it is the stuff for fixing mistakes in PC boards.
Yeah, I know.
What colors do you have, Pete? I've
got
blue, but I need some other colors.
I've in addition to those colors, I've got white, black, yellow. Hold on a second. With the miracle of Bluetooth, I can walk to the box of wire. Now, my box of wire is approximately 8 by 2.5 by 5 inches, and it's heavy. Green, yeah. So black, blue, yellow, white, green, white. I already said white. And they're pre-cut. This is all pre-cut wires, so you can the wires you're looking at, I didn't have to mess with them or strip them or mess around with them. And the 30 gauge size can actually I have fixed. I've soldered to very fine pitched chips using this wire. So anyway, and the formal name of those two wires is Bodge wires. In case if any of you guys listen to the amp hour, you'll know that that's the official terminology. The funny big white and black wires were part of an experiment. They disconnect 2 of the signals from the USB chip and allow putting some circuitry in between those 2 endpoints. And I was doing some experiments and decided to just go with the simplest circuitry. Okay, so here's a really quickie.
The wires that you have, Pete, are the wires that you're using for that? Are they just like old 30 gauge or 32 gauge wire wrap wires?
These wires?
Yeah.
The black and white? No, believe it or not, they're.
No,
Pardon me?
The red.
Yeah,
That's
the red.
Kynar. That is 30 gauge Kynar insulated wire wrap wire.
Yep.
Okay.
I do have a box of those.
And these are jumper solderless breadboard jumpers, and I just whacked this off, soldered it on, and there's a blob of epoxy.
The tin can in the center is a ESP32C3, which is a RISC processor. It has Wi-Fi and Bluetooth LE built into it. So the entire thing, the USB connector is simply for power. It can be used to program it, but this thing is sort of standalone and programmable over Wi-Fi.
Yeah, Nick's going to be talking in just a second about some of the Wi-Fi capabilities. We can program this through the USB. We can program it either using the Espressif IDE or the Arduino IDE. Here's a quick look at the bill of materials, and I thought this might be of interest because I don't know what happened, but going offshore was against my religion until fairly recently, and I think Nick's been a very bad influence on me, and he's gotten me to notice that you can buy stuff.
I wish I could say I had the same effect on women.
Right. Well, anyway.
That might be an insult, Pete.
So some of the prices bought direct straight from China are astonishing. I can't remember the Nick, you bought a batch of these USB interface chips. The other day you bought 20 of them. Do you happen to remember what you paid?
I think I paid $1 a piece, but that was from eBay via China.
Oh, that's right. It was eBay. Yeah, and so they take a cut. There's an outfit that is kind of a holding. It's kind of a Chinese eBay in a sense.
AliExpress
that offers these things at like 9 cents each.
Yeah.
And just for the record, I would not ever use these kinds of parts for a client, for something that I was doing for a client, just because I couldn't tolerate the drama, the potential drama of using a 9-cent USB chip. If it had actually been swept up off of the floor of the factory. So anyway,
the greater than 5% dead on arrival rate.
Right, exactly. So we're in a prototyping phase right now, but also for some of these chips, if 5%, I mean, we may have to figure out how to test them. But Nick's had a lot of really excellent luck with these chips. So if there's anything wrong with them, we'll blame him. No, we won't.
That's also what the women have said.
Right. So anyway, as you can see, we can get under $10, and let's see. Next thing is firmware status, and over to Nick. Shall I put the first slide on?
Yeah, there are a couple simple. This is the initial page. The home page gives you what the CPU. This is all wireless. It's all embedded on the ESP chip. It tells you the ESP chip, gives me a whole bunch of information, and tells me the SCL and SDA, which are the I2C clock pins, just some useful information. What it does is when it starts up, it does an I2C scan. So the next page is the I2C scan, and it gives me a report back on all of the I2C devices that it finds. In this case, the four ports it found were the dialog chip. Anything here, any other chips that it found would show up here. You can also click on any of the numbers and individually address that chip so that the 0, 1, 2, 3 are active elements. So if you want to go and probe them further, you can go in and do straight I2C functions. This entire thing is written in a JSON scripting language, and so the next page is an actual dialog interface. This is all scripting, all scripted from the I2C stuff. This is a dump from the dialog chip has 2 pages, which are 256 bytes or 2K kilobits long. This is a dump of the page. You can actually click on an item and go in and change it if you know what you're doing. There are 2 pages. There's the NVRAM and the double EEPROM. You can load either of those pages. You can clear either of those pages. You can save either of those pages. This reads the direct output of the dialog file, so that when you're done with the dialog tool, you've got a design. You simply save that in the normal fashion. You hit load. It takes reads the dialog file, interprets it, loads it out to the chip, and programs it. So you can program the NVRAM or the EEPROM. I spent a lot of time trying to make this look very simple. It also has the ability to, by talking directly to the ESP chip, you can, I don't have the page, but there's a charting function. So you can actually develop a graph of the data that you're looking at. So you can take the output of the instrumentational amplifier, feed it into the, put a jumper that feeds it into the ESP chip, set up a loop, and graph the output of that chip. It also has a light function, which is designed. It's hooked into some LED, programmable LED lights that I have a lot of. So the first demo project I'm playing with is to get the lights so that I can control them with my muscles. Put a probe on the muscle, go in through the instrumentational amplifier, go out and see if I can trigger to turn on one of the LEDs. So that's what the other functions here are. The ESP function is just some ESP stuff that helps me program that. So spent a lot of time trying to make this look as simple and as clean as I could.
So this is a ESP32C3, correct?
C3.
Yeah. Okay.
It'll run on any of the ESPs. There's nothing specific to the C3. The C3 is the newest. It's a RISC chip. It's right. It's the smallest package. It's the lowest power. It runs a lot faster if you run it on a regular dual core ESP chip. But as you know, for $1.50 a piece, the ESP32C3s are quite nice chips, and they're coming out with dual core versions of that. So it's it wasn't the simplest choice to make.
So it doesn't have built-in Wi-Fi then, if it's only a single core.
No, it has built-in Wi-Fi.
It does.
Built-in
Now, what
Wi-Fi.
if you got a ton of the chips from the old ESP01s? I've got a bunch of those. Or what are they? The 8266 chips?
Yeah, the 8260. Yeah, I've got some of those. I don't know that it'll run on that.
Okay.
The 8266s are a different architecture.
Right. They are.
It might run. I've got some. I've been focused on the C3s at the moment. Let's say it's just because they're, that was the target. I don't. It probably would run fine on the on an 8266. I haven't tried it. I've got a pile of chips on my left hand side, and pulling out some 8266s would just make the pile bigger. But anyway, that's the dump of the dialogue chip. It does an I2C scan, automatically finds the dialogue chip, automatically then downloads the EEPROM and the NVRAM to this particular page, and then you can the dots. I don't like looking at pages full of zeros. I think it's meaningless to me. So I put dots where there's a double zero. You don't like it? Tough. Trying to think what else you need to know. That's it. It's relatively simple code. It resides entirely on the ESP. Go ahead.
So you interface with it using your web browser and a Wi-Fi. So you point your computer to it, interface via the web pages, and upload the files that come out of the synthesis tool.
Yep, it's entirely web-based. It comes up to a default SSDI, which is, well, it actually always has the default SSDI loaded. You can load in your own local SSDI, and it will connect into whatever your normal network is and do a DHCP, so you can find it on your normal network. But you do the provisioning by setting it up through the default interface. That's it.
Okay, just to finish up, as I mentioned, the next meeting, here are the details. We'll put out another reminder when it gets closer on the TriEmbed list, as well as the signal group. One thing to be thinking about is as you learn more about FPGAs and especially the kinds of applications that they shine at on, think about applications, because we're going to be getting close to the point where we can start programming the chips and turn our attention to applications and making demos, starting with the one that Nick outlined.
What's the tool chain for the FPGA programming?
It's simply one. It's a very well written, fairly easy to use drop and drag interface, similar to the software-defined radio. It's easy to download, works on any platform, and you simply lay down an op-amp, and you connect the op-amp to the appropriate pins. You connect the resistors. You build your circuit there. It has some internal resistance, but not much. So if you're going to put resistors, those go outside. But there's no you don't have to know any FPGA code. You can do it that way if you're a masochist. But so you just connect your circuit.
This is it's a very, very simple step in the direction of before you start using Verilog or VHDL.
The way both Nick and Pete have been describing this, there's been a series of articles in Nuts and Bolts magazine. It's over the course of the last year. There's been 4 articles now. If I in the same email when I send out about the Hamfest, I'll send out the pointers, the issues, and page numbers where you can find those articles if you're looking for them.
That would be interesting.
And I think, Nick, they're using the exact same tool chain that you guys are using.
And the dialogue chips?
I suspect so. I'll have to go back and look.
Yeah, I'll be interested. I mean, it's let's say yes, I'd be interested. Great minds think alike, I guess.
So here's a few resources. If you want to look at the current state of things, there are 2 repositories on GitHub. If you jot down this, oh boy, that's a real easy to jot down URL. But anyway, I'll put this. We'll put this in a message to the list of the where these slides live. And also, there are notes from the previous meeting group, working group meetings, and they're linked together. And if you go to the PDF and you click on these links, it'll take you there. Any other questions?
Pete, yeah, did you put the link to the video in the last meeting? I tried to do it, but I realized I couldn't edit.
I'm confused. Did you say putting a hyperlink in?
Yeah, did you put the hyperlink in the last meeting, the FPGA notes, to the link to that video that we did?
We did not. I don't think it's in there, but we'll make sure it goes in.
You know what?
I was going to put it in, but I couldn't edit. So
earlier today, there was a discussion about why I would want us to have access to those notes files in such a way that we could continue to modify them. One guy was joking that I wanted to add graffiti, but darn if we don't have a good application. So yeah, we are still able to edit those notes. And we will take care of that. Yeah, for sure.
All right. Thank you, Pete and Nick. All right. Let's just do a quick survey to see which people have show and tell. Is there anyone that wants to do show and tell tonight? All right, sounds kind of wide open. Well, we can call it a night.
Actually, no. Well, I'm so challenged. I hesitate to even try to do this, but I'm sitting next to a vector network analyzer that is cool beans in as far as I'm concerned. And why don't I see if I can present that next time? But basically, this gadget, it's an extremely inexpensive, extremely powerful device for measuring impedance and standing wave ratios and signal magnitudes and so on. And I'll see if I can come up with a show and tell for next time.
Who made it?
Oh, the Chinese.
Oh, okay.
It's called the Nano VNA, and they were selling for like 30 or 40 bucks. I think they're up to 50 or 60 now. You can get Cadillac versions for a little bit more. I'll like I say, I'll make a proper presentation. But I've been having a lot of fun with this. It's for those of you not familiar with VNAs. If you roll the clock back just a few years and you ask somebody how much does a VNA cost, they would add at least about 2 zeros,
Maybe
so
30.
there maybe 3 zeros. They are extraordinarily expensive, but darned if they didn't come up with, these guys came up with ideas to use microprocessors and relatively inexpensive hardware, and they made VNAs that are accurate enough to be very, very useful. So we'll just call
I
this
remember the ones on the job where I worked were like $15,000. There was another one that was almost $50,000.
yeah. But now its specs would have a little bit of an edge on the specs for this VNA, but for casual use, it's astonishing. And
What's a DNA?
a vector network analyzer. Vector network analyzer. It's a what is it? It's a gadget that puts out signals and it measures reflections, or it puts a signal out and it measures the reception of the signal at into a second port, and it gives you information about the magnitude of the reflections, or the magnitude, the amount of attenuation, the amount of insertion loss, standing wave ratios, and so on. And I'll see if I can put together.
If you're doing line driver stuff and you're measuring long lines, you can actually measure where every splice is. You can measure where every kink or break in the wire might be.
Yeah,
Not with this one.
Man, this is something I could have used back when I was doing radio work.
Yes.
With buried lines.
No kidding.
Stuff.
Absolutely.
Yeah.
That's my introduction was radio and television work.
I mean, I used to just throw an oscilloscope on the line and then send the signal down and look for crap on the scope, but it's not all that accurate.
Okay. We're going off on a tangent here. This does not do TDM. This does not analyze cables or show you breaks. That's beyond its capabilities, but it does a lot of other interesting things. Anyway, I'll see if I can put something together with some photographs so that we're not dependent on my camera and minimally dependent on audio, and maybe I can get my act together next month.
Okay. Anybody else have anything they want to share tonight?
Just the TARDIS and the DeLorean.
On a collision path.
Free rides?
On my T-shirt, yeah.
All right.
Well, the timing was pretty good.
Yep, we did great. All right, everyone. We'll see you in 2 weeks or in a month.
Okay. Bye-bye.
Alrighty.
Thank you, gentlemen.
All right.
Let me kill the.
Does somebody want to make sure they grab the conversation